Okay, so next up on my series of tools that I'm making to help me make and debug and analyze and use my project my forthcoming project, which is my homemade CPU project. I'm going to be making the output section, or a very simple decimal output section, so that you can take an 8-bit binary number and display it in decimal using my snap-off PCB. These PCBs are made by JLC PCB, so I designed the schematic on my computer, sent them away, and got the PCBs manufactured. And they're just dirt cheap, is what you could say about that. Not in terms of quality, they're excellent in terms of quality, but the price is very, very low. So what does this circuit involve? Well, I've got a 4-digit LED 7-segment display, which is going to sit here. I've got an Arduino Nano, which is going to go in here, and the input here, I'm going to use some pin headers. That'll be an 8, what's that? That's a 10-way pin header actually. 2, 4, 6, 8, 10-way pin header. Let's see if we can snap that. There we go. So an 8-bit binary number coming in here, and the Arduino is going to decode that binary number, turn it into a decimal number, and we're going to display the decimal number on the display. This is a cheap Arduino Nano. I bought about 5 of these, I think, by accident. I thought it was the full strength Arduino Nano with a 80 mega 386 chip on it, or 368, whatever it is, but it's just the 186 or 168, or I don't know what it is, but anyway, it's so feeble. It's got about, well, it's virtually got nothing on it, but even though it's feeble, it will still be able to do this job, because this job is not very much, is it? I've got to take an 8-bit number, turn it into a binary number, and send it to a display. So let's solder it up and see if we can get it working. Okay, well, I skipped over the tedious soldering there, but I have soldered those components in place. So this is the 4-digit LED display, and it runs on a 2-wire connection to the Arduino. There's just power, ground, and what it calls, well, you can't see it, can you, because I've soldered it on there, but it's what it calls something like data and clock. So it's just a 2-wire connection. It's got 4 pins at both ends, but all 4 pins are continuity checked, those, and they're all connected straight across, so it doesn't really matter which ones you use. And this LED is driven by basically you can download a driver for this quite easily. I'll put a link to that at the bottom in the comments for this, but put simply, you just download the driver file for this particular chip, the Arduino, basically the Arduino source code to drive this, include it in your project, and I've written a very, very simple project. It just reads the 8 data bits that are coming in on data lines, I think 2, 3, 4, 5, 6, 7, 8, 9, and then pins 10 and 11 are driving this 4-digit display. So let's shove a bit of power in there with the bench power supply turned on, 5 volts, power in. What's going on? Not switched on, and it's going completely nuts because there's no input at all at the moment. If I show you that, there's no input at all at the moment, so it's just reading random values. I think if I put my finger on it, I can probably, no, it's just reading random values. So what values am I going to be putting into there? Where would I be finding an 8-bit binary number? Well, funnily enough, I happen to have one up my sleeve somewhere. Let's grab it. Well, that makes an 8-bit binary number, doesn't it? My 8-bit binary number creator circuit that I made in a previous video. Let's connect the two together and see what happens. Right, so I'm just connecting the 8 data lines and the power and the ground between the 2 circuits. Okay, so I think I've got this working. If I put a small piece of masking tape over those numbers just to increase the contrast on them slightly. Got the decimal number currently being shown on the screen up here and the binary number on here, so that's quite nice actually, isn't it? This is sort of short-circuiting the entire project in a sense. So the point is that this is the input to my project, this is going to be the output of my project, but I haven't built my project yet, so I've just connected the input straight to the output. But it's quite good fun to play with, because if you put a binary 1, so a single light in the least significant bit of the number, then you get a decimal 1 up here. So you've got 8-bit binary being transferred from here across to here. I'm also transferring actually power and ground just to make life easier for myself. Decoded by the Arduino, sent to the display, and we get a 1. So if we stick a 2 on there, we get 2, next one we'll get 4, next one we'll get 8, next one's 16, 32, 64, and the most significant bit is 128. And then add 1 to it, 129, add 2 to it, 130, add 3 to it, 131. Play on this all day. Let's do a few at random. There we go, 37, so that must be, so that's a 1 and a 4 and a 32 added together, 32, 36, 37. So binary is a bit strange in a way, an 8-bit binary number, because the maximum you can get out of it, if you add everything together, is 255, which means the numbers go from 0 to 255, so there's 256 different numbers, which isn't the most useful amount of numbers, is it really? It's not really a round number or anything handy like that, but the whole of computing runs off it, so you've got to make the most of it. But the tricky thing about binary is that it doesn't really relate to decimal very well. So for example, like in decimal you go 0, then 10, then 100. Well, 10 is there, but where's 100? So that's on, off, on, off. 100, that must be like 64, 96, and 4 gets you 100. On, off, off, on, off, off. I mean, there's just, it's kind of tricky. It's sort of confusing. I don't think I could really work in binary without going completely nuts.